Hello and good evening. My name is Vishal Soni, and in this session, we are going to discuss about big data. To begin with, let's have a quick look at the current data trends. On this earth and beyond, every day we create around 2.5 trillion gigabytes of data, and this data is growing at rapid pace. It doubles in every 1.2 years and grows 10 times in every 5 years. This growth is so fast that 90% of the data in the world today has been created in the last 2 years alone. This data is coming from all sources, including social media, intelligent devices, and many more. For example, in every single minute, we get around 6 million Facebook page views, 1.3 million YouTube video views, 1 million tweets, and so on. Then we have all other sources like weblogs. There are over 2 million Google search queries per minute, and people send 144.8 billion emails per day. This all contributes to the bulk amount of data we are generating. Then we have a huge variety of devices, and the count of which is growing at tremendous pace. Statistics says that by 2018, over half of the IP traffic will originate with non-PC devices. By 2020, every adult individual will have around 4.3 connected devices with him, which would be probably more than the number of immediate relatives he or she has. This is just about the personal devices. There is also a huge network of intelligent things, which is known as Internet of Things, which is sitting around the corners of your home, generating data each and every second. Every single minute, there are around 217 new mobile users getting connected to the web. All these statistics correspond to the term big data. Big data is about the digital data all around us, which is large, rapid, and it appears in a variety of formats. It is large. At present, there is 2.7 zettabytes of data in the digital universe. The volume of this data gets doubled every 1.2 years. Facebook alone owns 30 petabytes of user data. And this data is flowing around at rapid pace. Every year, 1.1 zettabytes of data flows through the digital networks all around us. The New York Stock Exchange captures 1 terabyte of trade information during each trading session. Also, this data is coming around in all sorts of formats, readable and unreadable. Every month, 30 billion pieces of content are shared on Facebook. Many of them are in the formats which did not exist 5 years ago. There are 9 billion devices connected to the internet at present, sharing data in various readable and unreadable formats. These all statistics give rise to the three paradigms of the modern data, what we know as big data. Big data is commonly described using three terms: volume, velocity, and variety. Big data is about data which is huge, much larger than the normal capacity of the traditional databases. Data which is flowing at random pace. Data streams moving in real time, virtually about everything we do and experience. Data which is diverse in nature. Data which we can understand or even which we can't understand using our ordinary devices and processes. This is big data. Here, volume of the data corresponds to the huge volumes of data extending to GBs and PBs and even more. It includes historical data stored in the data warehouses, having records about human interactions with any system. For example, for any single organization, it could be the daily interactions with customers for past 50 years. Or it may be the data generated by machines, like log files since their beginning. Velocity corresponds to the streams of data, fast-moving data flowing across the network channels and devices. It could be data generated in stock markets. Every stock market keeps generating data about the prices of the thousands of shares listed with them every millisecond. It could be weblogs and click streams. Each and every website keeps monitoring and recording the logs about the user interactions on daily basis. It could be streaming videos, millions of people watching videos, live or recorded session each and every second. It could be data generated by the sensors like RFIDs and many more. Then we have the variety, which corresponds to the various formats in which data is generated. It includes all the readable and unreadable data getting generated and stored in structured, semi-structured, or unstructured format. This includes the entire Internet of Things, millions of small devices generating data from every node of the connected global network. It includes medical reports, hospital records, X-rays, ECGs, and all sorts of patient information. It includes weather information, temperature and pressure sensors generating data about the climate changes each and every minute across the globe. It also includes data from RFIDs and various other sensors. It could be satellite images. These all sources are continuously generating data in a variety of formats which till some time ago we were not able to utilize. Why is it all important? Why do we care about big data? Statistics shows that organizations having better management and control over data are better capable of handling any risk or taking advantage of new opportunities. Till some year ago, organizations mostly focused on the traditional data stored in their well-structured RDBMS systems for the business applications like CRM and ERP. But now, most organizations have realized that they possess enormous additional data which they were neglecting so far. In fact, in most organizations, 95% of the useful data remains untapped. This includes semi-structured and unstructured data like emails, chat history with the customers, call logs, web logs, and all other digital footprints of their customers. 39% marketers say that they do not possess the right tools to harness desired information required to take decisions on time. 93% executives believe that their organization is losing revenue opportunities by not leveraging the available data properly. In short, most organizations now realize that they are not able to make best use of their data available to them. This is either due to the lack of right tools or due to some other technical or business limitations. Big data helps organizations deal with the above-mentioned concerns in two different ways. The first one is technology innovations. Big data drives on low-cost storage and processing power of commercial systems and can be enabled in any environment, be it on-premise, cloud, or hybrid. It includes new software patterns to handle speed and volume of data. For instance, it includes in-memory computing and Hadoop and MapReduce. These are the new concepts that are that has made capable the existing commercial systems to deal with bulk amount of data. It also brings revolution of the user experiences. Till few years ago, the only best mechanism to read the data was to have reports printed. But now big data presents with the ways, new ways and innovative ways where user can have look at the data in form of mind maps or heat maps. It also includes predictive analytics and data recommendations, which will suggest its user to take appropriate actions even before any mistake happens. It also includes automated responses and self-tuning systems. Besides these technology innovations, it also opens the door of a new world of data. Big data is capable of handling unstructured information like documents, web logs, emails, anything on internet, which were till date out of scope for the traditional database systems. It can capture data from sensors, RFIDs, intelligent devices, cars, etc. It also covers the data generated from Internet of Things. The trusted third-party sources or the open data sources, industry providers and aggregators, government open data, weather information, all these things can be captured and processed using big data. So, the new world of data, when added, the new technology innovations give rise to a huge business advantage. And this all advantage could be harnessed using the new term, big data. The traditional systems had a set pattern for capturing data. All the traditional systems, including CRM, ERP, and finance, had a centralized data repository which stored all the data in the RDBMS format. Then, from those RDBMS systems, the data was fetched and applied to the data quality processes like data refining, data cleansing, and that data was normalized to form a traditional data warehouse. From that warehouse, business users and the business analysts took out time to generate reports and present the data into useful formats. It included a lot of additional overheads. Challenges with the traditional systems. Storing the bulk amount of data was always a big challenge. Then processing the data in the timely manner, especially when the data is now reaching to the limit, crossing the limits of gigabytes and petabytes and reaching to zettabytes. Handling variety of data, the modern sources that we all discussed, were out of the scope for the traditional systems. Then to deal with all those, it also included expensive hardware. Then there were some technical limitations. The storage capabilities of the hard drives have increased massively, but the ability to read the data and write the data back on those devices has not kept up with the same speed. So it takes long time to read all the data on a single device, and writing of all the data takes even slower. The alternate solution that was provided during the data warehousing was splitting the disks and reading the multiple segments of parallel data, which can reduce time. But this gave rise to another problem. These kind of systems were not able to deal with hardware failure. Also, it was pretty much tough to combine and read the data from different sources placed across different data warehouses for quick analysis. Big data and Hadoop. Apache Hadoop Software Library is a framework that allows for the distributed processing of data sets along clusters of computers using simple programming model. Hadoop is considered as the core of big data. It comprises of a processing framework within the big data technology stack. It is designed to scale. It is designed to detect and handle hardware and software failures, and it delivers highly available services on the top of clusters of compute. Big Data Hadoop framework is pretty much cost effective. As mentioned earlier, it can utilize the commercial hardware available in market and don't need specialized expensive hardware to work. It can work in heterogeneous environments. It can work across systems having variety of operating systems. It is completely based on parallel processing, and we will see how it works. It works on the principle of moving code to data. By this, we mean that the traditional data warehouse systems, for doing any processing, they used to rely on moving the data entirely from one particular storage device to the processing engine, which took some time. But the new Hadoop-based systems move the code to the data, which means the processing capabilities are split into the different processing units, and those processing units directly move to the data storage devices. We will cover these all points in details in later sessions. It also takes care of the hardware failure via automatic failover. and it is very much scalable. It can extend up to 4,000 nodes. Also, it has very reduced complexity because data distribution and MapReduce frameworks takes care of the storage of data, and user can straight away focus on his own work. Traditional ETL approaches versus modern practices. How traditional ETL differentiates with the big data. Traditional databases had unstructured data attached as independent data units called blobs, whereas big data can handle all structured, semi-structured, and unstructured data in similar fashion. Traditional ETL systems were based on schema on write, which means that even before you write any data to the traditional ETL system, you must define the format of each and every field which we are going to store. While in big data follows schema on read approach, which means when you want to write any data, you just dump it into the system, and at the when it is time to read the data, then you can define the ways to read the same data in different formats. Traditional ETLs had a structured data model with relationships across tables, whereas in big data, all the information is saved in form of compressed text files distributed across various systems. So whereas in traditional databases, we had concepts of tables and rows and columns, in big data, all the thing that matters is the amount of data. Traditional ETL systems were based on two-phase commit methodology, forcing completely accurate results before generating the output. Whereas in big data, eventual consistency methodologies enabling correct results even before partially available data is there. How all these things happens, we'll be covering in details. Now let's have a look at the traditional data warehouse systems versus big data. In traditional RDBMS systems were capable of handling data size up to gigabytes to some terabytes, but big data can handle petabytes and even exabytes of data. Traditional RDBMS systems had interactive and batch format, which means the data was processed interactively on demand basis, but big data will deal with the data in batch mode only. Traditional database systems were focused on read and write many times. You can read and write the data as many number of times as you want. But big data is mostly concerned with write once and read many times approach. Traditional RDBMS systems had static schema for each and every data that was stored. But big data has dynamic schema. So you save the data once, and then you can define the variety of schema to read out the same data. Traditional RDBMS systems had high integrity and followed the ACID properties, whereas in big data, the integrity of data is very low. Traditional RDBMS had a nonlinear scaling capabilities, whereas in big data, the scaling is linear. That means the number of nodes you add to the cluster will directly correspond to the improvement in the processing capabilities. Also, in traditional RDBMS systems, the DBA ratio was 1:40. That is, you will need one administrator to handle 40 nodes, whereas in big data, you'll just need one administrator to handle around 3,000 nodes. Big data analytics versus traditional BI. Big data depends on experimental and ad hoc analytics, whereas traditional BI had repetitive workloads. That means when traditional BI systems were designed, they were designed for a fixed set of reports that they could generate, whereas big data can provide you ad hoc reports out of the data which is lying in the systems. Big data analytics provides mostly semi-structured data and reports, whereas traditional BI must have structured data to work on. Big data can operate on internal as well as operational data, whereas traditional BI need operational data for their operations.
volumes. Big data can handle tens of terabytes to hundreds of petabytes of data, whereas traditional BI systems are capable of handling some terabytes. Big data solution considerations. Big data is primarily suited for few situations. It is good when you have large volume of data to store and process. The data is semi-structured or unstructured format, often as text file, for example, log files. When the data is not well categorized, you don't know which data will be used for which kind of analysis, then you can use big data. The data arrives rapidly as streams or in large batches that cannot be processed in real time. For example, stock markets. The data contains a lot of redundancy or duplications, like we have in log files. The data cannot be easily processed into a format that suits existing database schemas without risking loss of information. Execution of complex batch jobs, even on large-scale data. Big data is also good when you want to be able to easily scale up the system up or down on demand. That means if you wish to add new nodes or remove new nodes based on your requirements, you can use big data.